Hey, welcome back, Federico.
Hello, Janine. How are you?
Yeah, very good. Let's go and see what we did last. Let's recap to everyone what we did last time. So we have. Let's bring the first in the screen. We have our application with a ring, and in the ring a few conveyors. Maybe you want to walk through the code we did last time.
Yeah. So the ring is the higher level cut, the higher level component of our application, and is in his children frame. Of course, it contains and it can control all the conveyors, the 7 conveyors of our solution of our application. Each of them is linked to another through this adapter I loop chain that for the moment is totally empty, and we are
Yeah.
going to customize it.
Mm-hmm.
And this frame organization is again reproduced inside each conveyor. Okay.
Mm-hmm.
So again, here we have the iLoop chain adapter in the input interface and the iLoop chain adapter in the output in a socket and plug form. That's what we did last time together.
Okay, very good. Maybe now it's time to add something in this layout, and I would suggest to start with modeling the photocell that we saw in the early video. That on each conveyor there is a photocell at the end of the conveyor, and we probably want to see the status of it and maybe do some actions later, depend on this.
Yeah, of course. On that signal, you build some logic. You know that a box is passing there.
Exactly. So let's add this one. To do so, we will use a library, I think the green library. Maybe you want to show us quickly how to add it in our project.
Yeah, of course. So the library is here, available.
Okay. And
Inside,
inside we can see exactly some application cat, and one of them is called digital input. So it's this that we want to bring to our application. Okay.
okay, let's bring it here. We can call it and photocell, for
Okay.
example.
Yeah, it's
Because in
always
this
very
case,
good. You should always name your blocks. If not, you will be lost when you will have FB1, 2, 3, 22, etc., etc. So
yeah,
yes,
especially when you have
name your blocks.
to map symlink or create HMI symbols. So yeah, it's
Exactly.
very important.
Very good. So now we have already the photo cell. Maybe we can start tackling the HMI part. So we have a conveyor with a photo cell. How can we represent this?
Yeah, the idea is that as soon as we are using a cat dedicated to this, we can customize his own symbol, his own HMI. Okay, let's go in the default and we can rename it, for example, as horizontal, because in our application we want to.
So we have one horizontal conveyor and one vertical, and you
Yeah,
created a S before. It's a small convention to say that it's a symbol. So
yeah,
S horizontal for symbol horizontal. Okay, sounds
yeah,
good,
yeah.
like a first symbol. Okay.
Sometimes you use FP just to create faceplates and just to
Yeah.
give command parameters and other stuff.
Mhm.
But now just a graphical symbol. Okay. So let's customize it. We can create a very simple rectangle here.
Yes, maybe you should not put it that big, but yes.
It's too big, you think? Okay, let's do like
Okay,
this.
let's see.
Okay.
Yes. And we
And
want to add the photo cell, and the photo cell is part of the component conveyor. So it will appear here in sub cats.
yeah, in this folder, it is available. We can just insert it here. Let's drag and drop it. Let's use just a simple sled for the moment and leave it here.
Okay. We'll probably do another one for the vertical one.
Yeah. So let's add a new HMI symbol, vertical.
And the photo cell is again at the end.
Yeah.
Okay.
Let's change a bit the position. Okay, perfect.
Looks good. So now that we have the ring containing the conveyor, containing each photo cell, we can maybe build our final HMI screens.
Yeah,
to see a bit how it could look like.
exactly. First, we have to check that our ring is properly mapped on our resource. In this case, just the eco runtime.
Mm-hmm.
So let's map it. Okay. In this way, the
Okay.
program will create all the cat instances we are going to use in the canvas. So let's create a new resolution. We can do like this. Let's leave everything standard. Finish. Inside, we create a new item. Okay, call it demonstrator, for example.
Mm-hmm.
And here, in the cat instances, we have all our convertible ready to be used.
We see that the numbers are not 1, 2, 3. It's because at the first video we did a copy paste and it continued the
Yeah,
numbering. But let's keep it like this. We know about it. It's okay. We are
yeah. Of
developers.
course, we can change it easily, but nothing
Yeah.
changed.
Yeah. So we have now, when we drag and drop it, we have the choice. Do we want to see this way of displaying or that way, horizontal or vertical? I
Exactly.
did to build this. Yeah. Mhm.
So in our application, the conveyor one is a bit longer.
Okay. Maybe you need to trigger a build. I see that the photo cell is not appearing
Yeah,
here.
let's build it.
Okay, now the
Okay,
photo cell is back. Very good.
we can do this vertical now because we create the first vertical object. We do the same here. Okay. Okay. That's vertical.
Okay, looks good. Now that we build the ring here, again, it looks like the physical world, which is good. Maybe we want to just deploy and see the final result in the canvas.
Yeah, of course.
So it's also while you do these steps in the tool of deploying the controller, then starting the HMI, I want to say a few words about vertical slicing. What we do here is that we do a minimal set of application, but we try to deploy it until the HMI. And this is what can be called vertical slicing, meaning that we don't start developing the whole code in the PLC, then the code in the HMI. No, you take few small functionality in a vertical way, and you try to deploy it fully. Like this, you did all the steps, and then we will add functionalities.
Yes, exactly. Before we do a deploy, of course, we have to change our network profile. It can be a local test, very simple. And also in deploy and diagnostic, we switch to local test. Okay.
Mm-hmm.
Now we can start a runtime simulation. Perfect. Now I'm able to log in. And we can deploy.
Okay.
Let's start finally our device.
The sound quality start to not be good. So now we have a device up and running. Very good. And I guess you start the HMI to see how it's going on.
Of course, start local HMI.
Okay, so the screen is representing correctly. I guess we have a bit of gray. It would mean probably that the library is not initialized properly, right?
Yeah, probably yes.
So I guess we have to start a event chain.
Yes.
Yeah, I let you do it. So it's in the resource directly.
So we have to use an event chain.
An event chain head, I would say.
Oh yeah.
We have to initialize the chain. Yeah.
Yeah.
So we have here the event chain head, and I think that these blocks from the green library start with the event called app_init, all in capital letters. So if you go to the name, right click, and add a constant, yeah, exactly. In capital letter, app_init.
Yeah.
Okay. And then we can initialize this block on a cold start. So init, and at the end of the init, we should trigger. So at the init output on the right side of the block, yeah, we should do a trigger, link it to the input block trigger.
Oh yeah, okay. Just close it in.
Exactly. Like this at the initialization, we do a trigger, and all the blocks inside will start actually. We can maybe just deploy this and see if it's already working better.
Yeah.
And then, of course, after we will refactor to have a better code. Okay, now we have to start the device. And let's have a look at the HMI part. Yes, now it's not anymore gray, it's black, showing that the photocell is probably off or not turned on. Very good. Just to finalize this bit, I would like to do a small refactoring on this block that we just did, the event chain head. So if you go to the, I will guide you. If you go to the code, usually I take then this block and I hide the complexity of this block. So I select the whole block and I right click, and there is an option to create a composite out of this.
Okay.
Yes, exactly. Create composite. And the code will look, and then I like to start it like, or name it library start.
Okay.
Library start, yeah. Okay. And like this, you hide in a block the name app_init. Okay. And like this, now it changed. So it created alone this with the right input pin. And inside the block, if you want to see, you will have the code that we wrote just a second ago. Very good. And then now if you go to the resource directly, it also replaces with library start. So like this, it's simplifying the way you see code, right? So we have a library start that is able to start the library. Probably we will improve the green library, having this functionality directly baked in, if it's not already baked and we don't know the name of the block. I don't know.
Yeah, it's possible.
It's possible, yes.
Yeah, in this way we avoid errors because we have to remember the name, app init, and so on. Yeah,
exactly. Okay. And thank you very much, Federico, for showing us the photocell in the conveyor. Let's see you soon.
Thank you, Genevieve. See you soon.
Bye-bye.
Bye.